Anyone know who this guy is? No? So when I was growing up, he probably had one of the most famous faces in the world, and certainly one of the most famous Irish faces. He's Samuel Beckett, arguably also a Frenchman. Fun fact, per capita, we in Ireland are the third highest in the world at Nobel Prizes for literature. Behind Santa Lucia and Iceland with one each, so I'm just going to go off and kill those people so we can be number one. That's excellent. Okay, so that quote comes from a scene which is about halfway through Beckett's kind of extremely famous magnum opus 1952 work, Waiting for Godot. I don't know about you, but I read that, and as an SRE, it just sounds like a lot of toxic positivity to me. I mean, maybe you might have a different idea. But it does have a sense of having arrived at some point and being somewhat nonplussed about what to do next, which we will touch on later. Of course, Beckett's mostly famous as a writer, but confirming all of your other prejudices about Irish people, and in particular about how every Irish person knows every other Irish person, Beckett knew my wife's granddad. So Beckett's on the top right there, and the granddad-in-law, James Gaffney, who was pathologist of a hospital that the Irish Red Cross put together in Normandy after the war, a place so famous for its utter destruction that a US soldier apparently quipped, "We sure liberated the fuck out of that place." So the photo is from Ethna Gaffney, my wife's grandmother and first female professor of chemistry in Ireland. In World War II, as I say, not just a writer, he joined the French resistance twice, and drove ambulances towards the tail end of the war and into that period where the Irish go and set up a hospital in France. And I mean actually in it, rather than just letting it be known casually that you were in it. Now, however, all of that fascinating history to one side, I think we would all agree that he is not an infrastructure guy. So, it makes it all the weirder that we named a piece of infrastructure after him, and it's like 100 meters that way. He would have hated it. Why, he would have said, do I, an absurdist, surrealist writer who made my name celebrating the fundamental tragicomedy of the human condition, have a bridge named after me? I mean, what's next? The James Joyce Nuclear Power Station? The Coca-Cola School of Dentistry? Even worse, this bridge, which as you can see is open for the maritime traffic of a celebration last summer, occasionally doesn't work. It occasionally doesn't close. Sometimes it just refuses to close, sometimes it closes, but the gap is like 2 meters, something you can't really drive over. Sometimes they lose the key, apparently, somebody once told me. So, enough about absurdist black comedy tied to pieces of critical infrastructure that occasionally don't work very well. Let's talk about AI. So, interestingly, on the right, Midjourney forgot the I bit of AI, which I think is pretty useful. So I think, slightly more seriously, one of the most interesting things about the historical moment we're in at the moment is that we have really strongly competing visions of the future, right? So there is a utopian vision, a lot of companies promising a lot of kind of bottom-up activity within companies, not even getting into kind of external commercial promises, not so much governments. I feel most of this is driven by the private sector. And so there's a lot of utopian promises with respect to AI. I mean, there may well be an AI utopia waiting for us, like we are being promised in some sense. I mean, generally, not just the AI SRE case, for which there is a ton of commercial activity, effervescent activity inside companies and so on. It may well be that the utopia is contingent on artificial general intelligence, i.e. equivalent human-level intelligence, rather than what we have now or what we could linearly expect. And by the way, I don't think the future is going to be linear. I just wrestle with this idea, maybe as an SRE, maybe as a professional pessimist, that utopia of any kind exists, or perhaps that its benefits would be evenly distributed. So I think a bit more about limits. And a well-known kind of book subtitle that I think about in this case is How Certain Schemes to Improve the Human Condition Have Failed, which is from Seeing Like a State by James Scott. The book talks inter alia about kind of hierarchies of control and measurement and how value can escape from those despite the best of intentions, and we don't always have the best of intentions. Which brings me to dystopia. Now, this New York Times bestseller book is in some sense a narrow response to the utopian view, and in some sense about a very different proposition than kind of a narrower AI SRE case. It's kind of artificial superintelligence. But if you don't believe the already well-known kind of Yudkowsky and Soares about whom you might already have an opinion, you will also presumably dismiss well-known extremists, Dario Admade, CEO of Anthropic, and Nobel Prize winner Geoffrey Hinton, basically saying there's a pretty significant chance a ton of this could go really badly. I suppose the one piece of good news here is that these are arguably infrastructure guys, so this is good, like it's one of our team. Excellent. So, I mean, I'm standing here on kind of a civilian in this world, in the AI research space. Both of those seem like possible outcomes to me. I mean, it's hard to know what to do about that and also about our specific case in the SRE world. So for the moment, for the rest of this talk, I will discard the worst case scenarios. And instead, I feel like we've been talking a lot about tactics at this conference, RAG and LLMs and MCPs and what have you. And I want to talk about something a little bit different, which is where we might end up, where all of these trends might land, what might happen to us. And so to do that, I'm going to invoke an oracle. Not that one. Not that one. Actually, he's not an infrastructure guy either. I am going to invoke a theoretical computer science oracle, which, I mean, we could get into the detail, but broadly speaking, it's a magical black box that answers a question in one step in a Turing machine. There's a well-known theorem called the Baker-Gill-Solovay theorem, which basically says that you can suppose the existence of oracles to answer certain questions, and it turns out that you can show that either P equals NP or not P equals NP, depending on the kind of oracle you assume. So they are not, in some sense, all magical, all question answering machines. But broadly speaking, we are supposing the idea of something which just gets it right. Or another way is kind of thinking about it is kind of AGI SRE. So what would it do? Like if we had this black box? And of course, it's not a pair of books, right? So there's no definite answer to be found in those. One question that we might ask ourselves when we're trying to answer that other question is how do we model what it is that we do in SRE? And I think some of you will probably be familiar with this. It's a diagram called the Dickerson hierarchy, urgently in need of updating, but we are working on it. But it basically tries to put some kind of hierarchy or model around elements in production and how they might depend on each other. And I think that actually probably the best bit about the diagram is that, in fact, most things do depend on monitoring in some sense or other. But if we had an AGI SRE or also AI SRE, where would we point it in this diagram? So answering that would be a key question to getting the most value out of what we're doing here. And I don't sense that from the talks that I see and the promises or otherwise on websites or in software that I read. I don't think I see many people targeting this effectively. Another way of modeling what we do is to think about our value delivered in the context of the standard software development lifecycle, SDLC. So right now, SRE leans in pretty heavily on design and testing and integration sometimes a little bit on implementation, depending, but we would expand the maintenance block a lot, and then there's kind of sub loops within that and so on. I would say I know I'm kind of proposing a world where we have some choice about where this incredible power gets pointed, and maybe we don't 100% have that. But I do want to call out a special case here. And a useful example is incident response, where there's a ton of folks, I mean, there's ambulances again, there's a ton of folks working on AI SRE in the context of incident response. And I think that this has tremendous promise and also some tremendous difficulty. Anyway, that special case to one side, I do want to talk a little bit about reasons to believe that the progress of AI that we are seeing right now is going to have more impact, meaningful impact, possibly even AGI style impact on what we are doing. There's also an argument for generally as well, but talking specifically about what we are. So one famous graph in this world is the meta graph about the length of tasks that AI can do. And that is basically doubling every 7 months. And so if you think about the kind of tasks that you were able to get a machine to do in January and you compare them to now, there is a meaningful difference between those tasks. And anytime you see kind of exponential, doublings, there's a sign that some serious mechanism behind the scenes is powerful. And I mean, this is they call it the bitter lesson thing in AI, where essentially the idea that you just pour more compute into the thing and it does better. Now, another reason to believe, quite apart from generic, task length power that's doubling, another reason to believe that we are going to see more effect is the fact that specific tasks, in particular those that are, shall we say, more amenable to a technique called reinforcement learning, where there's kind of definite right answers and wrong answers. They used this a lot for kind of the early chess playing AIs, in DeepMind data in particular. But the International Mathematical Olympiad also had AIs partaking this time, and a few years previously as well. And this time they scored kind of gold medal equivalents, so 6 out of 7 problems solved. The most interesting thing from my point of view, I suppose, as a person who spends a lot of time dealing with weird ass shit, particularly in production, is that much fewer special accommodations were required to interface between the AIs and the problems in this case. There were kind of special accommodations of various kinds required previously, and they're no longer required. Now, another reason to believe, if you happen to be a capitalist, or even if you don't, is that if this thing can be spent into existence, we are doing our level best to do this. That kind of graph is the up and to the right that would warm the black heart of any venture capitalist you could care to name. This seems like a likely candidate, and from a metrics point of view, it's certainly happening. Another reason to believe, particularly in the production domain, this is kind of wonky, but this is kind of a wonky conference, is a principle from the 1950s known as Ashby's law of requisite variety, which basically states that if you have a system and it is capable of being destabilized, there's some set of destabilizing inputs. In order to restore it to stable states, you have to have a set of buttons along the side that map to the destabilizing input. So first of all, you have to be able to discriminate what's happening to you and divide it by type accordingly. And then you have to be able to reach for the right remediation. And Ashby's law states that basically if your thing is too simple, it can't do this. It can't do that mapping correctly. But actually, the software systems we're building right now are amongst the most complicated things on Earth. Like if anything is going to be complex enough to encompass this in some sense, probably what we're looking at is going to be able to do that. Another reason to believe is what I call the reverse Andreessen objection, which is to say that everyone imagines that their own specialization is going to be immune to this automation or AI thing that's happening. And so by the iron law of hubris, I assume that this is not true. And in particular, maybe the immunity is less than imagined. And it's kind of like those surveys of driver performance where most people think that they're above average, or, in this town, everyone is above average, etc. Now, I don't know, is Mark Andreessen an infrastructure guy? I'm not sure. Okay, so there are also some reasons to be skeptical, or maybe it's slightly more accurate to say there are limits. We might imagine some limits to the progress of this technology or the progress of its applicability on our situation. The first one I want to highlight is from a paper called Why I'm Betting Against Agents in 2025, a very bravely titled paper, I might say, from a chap called Utkarsh Kanwat, and I call it the Kanwat objection. And basically, he is noting that for any sufficiently extended task in production, which essentially involves rolling the dice n times, and they're independent events, and you have a 95% chance of getting it right, like actually after only about 7 investigations or frobbing of a knob or terraform destroy or whatever, you get down to 50% success. And actually that's just not good enough. In fact, 95% arguably isn't good enough. Really, the accuracy rate has to be 99.9% in order to get anywhere with any sustained activity. Now, Utkarsh also has some objections in the original paper about, or based on kind of context size and cost and a bunch of other stuff. I won't deal with those here because I believe they will be handled, or that they're kind of a less fundamental objection than this one. Now, another limit we might observe is from the famous paper talking about the performance or what happens to open source developers when they make substantial use of AI tools. And the answer turns out to be, again, it's a paper, metagraph. The answer turns out to be it is not necessarily a unitary win. In other words, you can, at the current state of development, spend a lot of time doing cleanup or corrections or whatever, so that maybe it's just not as good as you expected, and perhaps sometimes less good than if you were just unaccompanied. And I wouldn't, again, this is all so early and I'm just a civilian, but I don't know if I don't know how much credence to place in that result, given what I see out there in the industry about adoption and CEOs forcing other people to use their tools and so on and so forth. So, big question mark there. Another potential limit, apologies for the sign, by the way, is in economics, this question of de-skilling, which is basically you have some highly developed skill, you are doing something in your factory or your workplace or whatever, and then automation comes along and displaces that. That's the technical definition. Of course, we will talk about this again from another angle in a moment, but this may well have some implications from the point of view of training data, because it's a key point about the applicability of this technology is whether or not the machine can continue to get enough training data to be effective without humans. Now, Todd Underwood gave us a supervised learning isn't enough talk back in 22, 21, something like that. And of course, the training data corpus of the entire internet producing an LLM is another thing to the training data of fine-tuning, or, there are different kind of use cases here, but there is a question mark to my mind about what happens if you sufficiently de-skill the maintenance of production such that there is no ability or a decreasing ability to produce relevant training data. And I do think that might be a limit. Agents currently, again, maybe next October I'll have a different story, or next January I'll have a different story. But agents currently have trouble with world models, to the extent that there's a world model, as I understand it, the world model float in the language. And also kind of short-term, long-term trade-offs. There's some work, or there's some commentary associated with the International Mathematical Olympiad win that shows that the agents were kind of grubbing around in short-term goals without actually progressing meaningfully towards the long-term goal. And there's also two stories about a very early AI program that I love. I am convinced they are from Gödel Escherach, but I'm not entirely sure. But the first story is basically about this program from the 70s called Eurisco. And Doug Leinat writes in a book called Hal's Legacy, 2001, 2001's Computer as Dream and Reality. He says, in the late 70s, I built a computer program, Eurisco, that discovered things on its own in many fields. It's built from Lisp, if I recall correctly, and uses heuristics, kind of hence the name. To get it to work, I had to give it the power to tinker with its own learning heuristics and its own goals. I would leave it running overnight and hurry in the morning to see what it had discovered. Often, I would find it in a mode best described as dead. Sometime during the night, Eurisco would decide that the best thing to do was to shut itself off. More precisely, it modified its own internal judgment rules in a way that valued making no errors at all as highly as making productive new discoveries. And as soon as Eurisco did this, it found it could successfully meet its new goal by just doing nothing at all. Hard same, Eurisco, hard same. And there's another story as well, again about Eurisco, of course, where apparently in the course of learning how to play, I think some kind of spaceship or maybe naval strategy game, it learned that the best way to compete in the game was to find the location in memory where the high score table was kept and to put its own name in at maximum points and then just stop. So that's a nice paperclip maximizer story for you. Another potential limit to this is, of course, the kind of it works in theory objection, but then when you actually try and apply it, it's not clear that people are seeing the benefits here. I don't know, I'm super skeptical about some of this on both sides in some sense, because there is a paper from MIT, or a report, I should probably say, that says that like 5% of businesses are maybe seeing some value out of this. And then I also look at my LinkedIn feed and it's full of people talking about insane progress with constructing software. And I think those two things sit in some sense uneasily beside each other, though I can see how they can be both true. So anyway, there's probably some deployment limit or practical limit here that we might hit. Another limit or objection I wrote a little bit about previously, which is basically LLMs won't save us, that LLMs themselves are maybe not the right architecture for this. In fact, since I wrote that about a year ago, some of those objections have been addressed. We now have more of a handle on hallucinations, not necessarily their prevention, but their prediction in the world where you can model an LLM as being a kind of a compressive entity. You can kind of detect when it's going to reach into the bucket to make up some shit in order to replace the thing that it compressed away out of existence. And so that's a promising avenue to explore, but there's still some potential limits there. And another potential limit, which is maybe most relevant in the case of incident response, but also, diagnosis, maybe some automation, etc., is this guy, Donald Rumsfeld, probably most famous in our community for saying this or describing this famous quadrant, which I've spoken about before, which attempts to divide, incidents or events or things that you classify into known knowns and unknown unknowns and the variance on that. And not to go into too much detail here, but in essence, known knowns are things that you can recognize when they happen and you know what to do about them. And for unknown unknowns, you don't know either of those things. So known knowns have lots of precedent in the training data. And so we might well expect an AI to be able to map Ashby's style input to output in some useful way. But unknown unknowns, almost by definition, don't have much precedent in the training data. if what we are looking at is a machine which is going to just reach into the training data, then we are not going to solve unknown unknowns that way. Also, he wasn't an infrastructure guy. Okay, but maybe actually all of those kind of will it, won't it kind of discussions won't matter. Not in the sense that we are East German nihilists, but in the sense that there's already enough going on in what we see for us to talk about a bunch of likely consequences. And here they are. So I won't read them out here, but I list them so that you can come back to it when we're looking at this later. So I don't even say this is a likely consequence, like it's happening right now. So we already are getting more lines of code. Now, the interesting thing about this is that either our intuitive model that lines of code represent risk in some kind of statistical way, like proportional to risk, and that will either have to change or we will have more risk, right? Like one of those two things is true. And regardless of whether or not that model changes, we will have more bottlenecks. We're dumping more code into this socio-technical system encompassed by the SDLC and a whole bunch of other stuff, but we've just literally opened the gates and shoved 10x stuff into it. We'll have more bottlenecks. Stuff will get blocked elsewhere, or if it doesn't, more stuff will go wrong. And in particular, we will see more edge cases. More on edge cases in a moment. Staffing reductions, I think that is extremely likely consequence of what we're seeing. My personal expectation right now is that on balance, I would imagine that's going to be likely temporary, because what we have effectively done is given decision makers, product folks, engineers, all this kind of stuff, the ability to mash a big button saying add complexity in return for revenue, and they are pushing it for all it's worth. So that complexity will either have to be entirely managed by the machine or us. So I was saying early, or kind of more edge cases. I think there's two things going on here. The first one is that if we had a machine which could, in some sense, take care of one section of the Dickerson hierarchy or some subset of automation or whatever, strictly less than pure AGI here, right? But if we had some machine that could take care of it entirely, then that being automatically handled in the known knowns case means that the things which will come to our attention will be edge cases. They will be the things for which the system did not work. And as a result, we will see more edge cases because the machine is moving faster. We are pushing more stuff through the system as a whole. Another likely consequence is the concentration of risk. So I think we are probably accustomed to thinking of risk concentration in some sense as an external dependency. I mean, I know it's more complicated. We'll get onto that in a moment. But we are all in some sense dependent on AWS, GCP, Azure. Some of us are dependent on both or more, or et cetera. Of course, it's a bit more like this internally. This diagram is actually hilariously wrong. I got ChatGPT to try and draw a diagram of internal connections between systems, and I like how this is wrong so much that I just kept it. But actually, what I really mean is this, which is to say that if we do a lot of AI SRE, and if this AI SRE involves third parties like Newbird or Cleric or Cereus or whatever, and those in turn rely on proprietary model companies, or I shouldn't say proprietary, sorry, foundational model companies, maybe even if they're using kind of open models internally. But it is a concentration of risk, because previously you had 100 teams which would act in some uncorrelated fashion when it came to resolving an incident or some larger scale outage, possibly even industry-wide or cloud provider-wide outage. But now all of those things during instability will use centralized platforms that will have more correlated responses. So this might be good from an individual company point of view, like you're raising the bar possibly on your internal incident response while lowering the bar potentially, or making the worst case worser for the industry as a whole, which is something I don't know that regulation or best practice is super geared up to talk about. Another thing I think will happen is, maybe also already happening, roles in the production engineering space are going to get more senior weighted. In some sense, juniors are at this very narrow moment in history already regarded as being somewhat of an imposition or a significant cost, or however you put that. Certainly they'll be expected to ramp up more or ramp up quicker and do more. And if the stack kind of facilitates that, you know, fantastic. But the overall stack is going to be more complex as we add more of these things. And the real question is, can we forget the additional complexity faster than we are adding it? Do those details of the addition of these systems, are they going to float around in our mind forever? Or can we successfully forget them? Can we get the machine to forget them? This is the big question in essence. Another kind of consequence, I think, coming back to the de-skilling point, is that as well as kind of labor being displaced in the broadest sense, but also a particular work stream you have in your mind as a model, those workflows are in some sense cognitively cached. If you do them regularly, you refresh them. You're running the playbook every day. Eventually you get pretty familiar with it. But if you don't do it for 10 months, you probably are not familiar with it. And so that question again, what can we successfully forget? Is the right analogy long division, which I successfully forgot 40 years ago? Or is it surgery, where I do not want to forget the surgical procedure, etc.? Or certainly don't want my surgeon to forget it. Another likely consequence relates to this question of simplicity, but also the incentive structure that comes into play when AI makes certain things easier and certain things harder, which is to say, in the old style Google, we used to say the internal tool chain made easy things hard and impossible things hard, which was a net gain because the company did a ton of impossible things or whatever. Okay, fine. Now we have, or theoretically, we have an AI system that makes doing easy things easier because you can just press a button to get a bunch of more complex behavior. But the behavior that is out of scope for reproduction by the machine because it has no precedent in the training data, like writing Rust or something, means that if you have to do a hard thing, certain things now become hard because they are no longer doable by the machine, and possibly even harder over time because more people will elect not to write their stuff in Rust because there's not enough help available from the machine. So there's potentially a feedback loop there that we might want to be aware of. And in particular, there's maybe emerging a kind of a Swiss cheese model of SRE where bunches of our work are kind of removed. Okay, like maybe that's fine. But I guess the question I asked at the start of this is, what do we do? What do we do now that we're happy? Now that we have achieved our goal of making the machine do more, or all of our work for us, do we become more about human-facing kind of senior style roles, glue work, that kind of stuff? The profession probably looks different overall. I think there's unquestionably still a need. I mean, even in the build-out phase of this, we're adding a ton of complexity. Even if it's not well understood or widely understood immediately that there is this need, I believe that this complexity will have to be addressed in some way. And of course, even if we're not called SRE, there's plenty of staff engineers that are not doing primarily business logic, plenty of folks in developer experience and so on and so forth. There's lots of positive possibilities, of course, right? New capabilities, lots of energy, etc. But Again, all of this defined for kind of pre-AGI, right? I think it's a different thing after that. One of the things that this question of what we do now relates to is, of course, the competing definitions of SRE, right? So we often have a lot of kind of identity-related conversations, and I think this might be one in that series. One definition of SRE that I've come across in the industry is call center but good. Some folks in the enterprise and read the SRE book and came up with or left with this impression. Another potential angle here is kind of temporarily embarrassed staff engineers. So there's this saying that poor people might regard themselves as being temporarily embarrassed millionaires, right? And in that sense, talking about how a lot of our work is often cross-cutting, has a cross-system view, we often connect many different groups and so on. We might think of ourselves as kind of temporarily embarrassed staff engineers. Or coming back to SDLC and Dickerson hierarchy definitions, we might think of ourselves as the non-functional requirements mavens, right? So anything which is not the business logic, we can do. And actually, there's more precedent for that than you might think, in the sense that often security gets melded in with other SRE-style tasks. And I sense that maybe some of the impetus for this will increase. Or also, the time-honored, what are people shouting at you about? Well, you could do that. Which of course has some problems as a definition, but it does at least have the virtue of being responsive to need, which is maybe going to be more important. So the question of what to do in a time of change is that even if you can't join the resistance, you can still drive ambulances during the war. Thank you very much.